this problem right here. I mean, everybody knows what the answer is, right? Okay, what's the answer?
4. Minus.
Okay, so you do have to be a little bit careful with this. The answer is, we're going to take the square root of both sides, right? Okay, and the answer is plus or minus the square root of 16, which is plus or minus 4. Okay, now, if you grab your calculator and type the square root of 16 into your calculator, what does your calculator say? It'll only say 4, right? Okay, so your calculator will give you one answer, as we've talked about before, because that is a function. Its job is to take whatever you plug in and give you one answer in return, right? So we know how the square root works, and we know how to compensate for the fact that our calculator will only give us one answer, and yet we're solving an equation that has two answers. Again, you could solve this by the square root property. You could also solve it by factoring. You could move the 16 to the other side. It would be x squared minus 16, do difference of squares and stuff like that, right? So there are two answers to this, even though your calculator only gives you one. I want you to keep that in mind while we're doing this next section, okay? So we're going to read through this really quickly. It says, we've learned to solve very simple trig equations, okay? We've actually solved stuff like this before, okay? But remember, there are a lot of details we need to keep track of, okay? We can solve this using, and I'd like you to underline this, you can solve this problem using a calculator. You can solve it using the unit circle, okay, or drawing triangles. Okay, you can also use a graph to solve this, and hopefully I'll be able to show you all three techniques today. Okay, but no matter which way you're doing it, there's really no substitute for you thinking about the problem, thinking about the equation, and using your brain to figure out, okay, do I have all the answers? Have I written down everything? Like, we could just say, as some people did at the beginning of class, that the answer to that original equation at the top there is just 4. It's not. It's plus or minus 4. Okay, so you got to use your brain in that sense. Okay. So we want to make sure that we cover all the details. And please make sure you read the instructions. Okay, I've set up most of these the same way. You do need to make sure that you're reading the instructions and make sure you give it the answers that it's looking for. Okay? All right, so let's take a look at this problem right here. What I want you to notice first is it says all solutions. Okay? Another thing that you want to look for in addition to, does it say all solutions? Does it say I only want the answers in a particular interval? Is does it want them in radians or degrees? Okay, I'm going to do this first one in degrees. All right, so we'll answer this first one in degrees. Okay, I'm going to do this one by drawing triangles and thinking about the unit circle. So here's what we're asking on this equation. We're asking what angles have a sine ratio of radical 3 over 2. Okay, and if you've still got that unit circle memorized, okay, we could draw a quick sketch of this and we could think sine is the, which coordinate? The y coordinate. So if you think about the unit circle, okay, it would have a y coordinate of radical 3 over 2 right there, right? How many degrees is that? 60 degrees, okay? Is there any place else on the unit circle? Bob?
120.
At 120, so over here, right? So this is at 120 degrees. That would work as well. Okay, now, if this says find all solutions, okay, couldn't I take this one and say, all right, one of the answers is 60 and another answer is 120, okay? But this says all the answers. Could I take this and say, you know what, let's go around the circle again, find another answer that's coterminal. Could I do that? Yeah, so I could add 360 degrees. Could I go around 2 times around the circle? And could I go counterclockwise, clockwise and go in the negative direction? So here's what we do for that. To indicate that, we say, all right, I can add 360k. And k is any integer. Now, can somebody remind us what an integer is? Yeah.
Whole number.
A whole number
Sides.
on both sides of 0, and we include 0. So k can be any positive or negative whole number, including 0. Okay? So again, don't forget what an integer is. Okay? So this is like shorthand for, okay, here are all the answers that are coterminal with this one right here. So if I plug in a 0, what do I get out of this?
60.
I get 60. If I plug in a 1,
420.
60 plus 360, 420. If I plug in a negative 1, 60 minus 360, so that would be negative 300. So negative 300. Would negative 300 be coterminal with positive 60? Yes, it would. Okay, do you see how that works? Okay, So then I'm going to do the same thing for this one, and I'm going to say that answer set would produce all the answers that are coterminal with positive 120. Okay. Are there any questions on how to set that up? Okay. Sure? All right. Okay, so that's how we can solve it by looking at the unit circle and drawing triangles and stuff like that. Let's solve this using our calculator. So if I were going to use a calculator to solve this, here's what we'd do. We'd say x is equal to sine inverse of radical 3 over 2. So make sure your calculator's in degree mode, and let's type that into the calculator. So let's see, I gotta get in degree mode. And we're going to do sine inverse of radical 3 divided by 2. It says 60, right? Okay, now, here's what I want you to keep in mind when you're solving something on the calculator. Okay, and this is why in chapter 4, this is why I had you think this way about inverse trig functions and why I had you draw these pictures. Okay, remember that sine inverse gives you answers in these quadrants right here, in quadrant 1 and 4. Okay, so your calculator will give you these answers. You need to use your brain to figure these out. Okay, so here's what the calculator said on this one right here. The calculator says that an answer that comes from this right here is 60 degrees. So if we've got an answer that our calculator gives us in quadrant 1, that has a y-coordinate of positive radical 3 over 2, could we take this, and remember doing this when we were solving stuff kind of like this before? Take this and flop it over here. Okay, if this is a 60-degree reference angle, that would be a 60-degree reference angle. So we're going to take 180 degrees, and what are we going to do with 180 degrees to figure out where this angle is right here? We're going to subtract 60. Again, we're always referencing it with the x-axis. Okay, so we're either going to make an adjustment on 0 or 360 on this side, or we're going to make an adjustment on 180 over here. So if I subtract 60, that gives me my answer of 120. And then if I want to write down all the answers, the first one is 60 plus 360k. That means I can start at 60 and go around the circle as many times as I want in either direction. And the other one is going to be 120 plus 360k. Okay, any questions? Good? Okay, one last thing then. Let's take a look at the calculator. And let's look at a graph to solve this. Okay, but before we put it on the calculator and have it help us figure out what the answer is, let's think about what the sine function looks like. Okay, sine function starts here and goes up, right? It starts in the middle. And I'm going to draw the beginning and the quarters. So here's what the sine function looks like, right? Or something like that. We'll fatten that out. Okay, that's sine of x. Let's think about what y equals radical 3 over 2 would look like. Okay, now, does anybody remember what that is as a decimal? If not, we'll grab our calculator. Let me ask you this. Is it bigger than 1 or less than 1? It's less than 1, right? It's about 0.86, okay? So if I were to draw that, that line looks like this. Okay, let me draw it a little bit bigger so it looks right. Okay? So you'll notice that this intersects here and it intersects here. Well, guess what degree that would be, and guess what degree that would be? 60 on the way up, and what on the way down? 120 on the way down. Another way to think of it is it's 60 degrees away from this right here, and it would have to be 60 degrees back from this right here. If this is 180, we back up 60 degrees, that would put us at 120. Everybody good there? Any questions? Okay, is this a good enough picture for the whole thing to get all the answers? No, because what would happen to this? This would continue going up and down like this. So this red graph, if we extend this, whoops, let's do red, would look like this, okay? So it's going to hit here and here, here and here. And notice, how far would it be from this point where it intersects the red graph on the way up to this point where it intersects the red graph on the way up? 360 degrees, because what's the fancy word for that? The horizontal distance needed to repeat that pattern? Period, because the period's 360 degrees. Everybody good with that? Okay, let me just show you really quickly how to do this on the calculator. If you're in degree mode, we can put this in here, and I'm going to clear all this stuff off. I'm going to type in the sine of x, and the other graph that I'm going to put in is radical 3 over 2. So we're going to do the square root of 3 divided by 2. And then we want to be smart about the way we set the window up. What's the x-axis measured in on this particular graph, the way we set up the problem? Degrees. Okay. Should we go from negative 6 degrees to positive 6 degrees?
Absolutely.
Probably not. Okay. Should we go from negative 4 to positive 4? No. We probably don't need that much space. So let's do this. Let's go from negative 360 to positive 360. Let's put a tick mark about every 30 degrees. And then let's go from negative 2 to positive 2. And that will let me see the entire graph. It should look something like this. Okay? And if I hit graph, there comes the sine function, just like we expect it to look. And here comes that guy right there. Much more accurate than the sketch that we drew. And if we wanted the calculator to solve these, and again, you'll notice that the distance from here to here would be 360 degrees. It's half the distance across the screen there. I can hit trace, and if I type in 60, look where we end up for a y coordinate. Okay, and if I hop on the other one, notice it changes just a little bit. But if I type in 60, there we go. And I could also have it do it by intersecting, right? Everybody remember how to do that? So I'd hit second calculate. Oops. Intersect. Is that the first curve? Is that the second curve? And is that our guess? It'll work for just a second, and it should say that x is equal to 60, which it does. Okay? Any questions? Sure? Okay, that's it in a nutshell. Okay? But let's go through and let's solve this one. This is another relatively easy problem. Let's solve this one in radians. Okay? So let's think about this one. Let's think in terms of the unit circle. Okay? I'm looking for an angle whose cosine is radical 3 over 2. Which coordinate is the cosine? The x coordinate. So I want the x coordinate to be radical 3 over 2.
That would be 60 degrees.
No.
30
Okay, yeah, we want the adjacent side to be radical 3 over 2. So we want that to be the large one. This would be 1/2. So what angle is this? 30 degrees, or in radians? Pi 6. Pi 6. Pi 6. Okay, is there another angle whose cosine ratio, whose x coordinate is radical 3 over 2, positive radical 3 over 2? Yep. Bob, where is it?
5 pi 6 or 50 degrees.
Okay, Bob says 5 pi 6. So I'm going to draw this over here, 5 pi 6. Is that right? Okay, somebody tell me what's wrong with that. Dylan, what's wrong with that?
The x is negative.
The x would be negative over here, right? We need the x to be positive. So where would it be, Lily? 11 pi 6. So I'm going to put one down here at 11 pi 6. Okay? Now, if we want to find all of them, again, we're going to write down an answer, and then we're going to write down how often it repeats. How far would you have to go around the circle before you hit the same answer again? Okay? So this is going to be x equals pi 6 plus, we'll say 2k pi or 2 pi k, it doesn't really matter. Okay? And the other answer set would be 11 pi 6 plus 2k pi or 2 pi k, it doesn't matter. Okay? So those are all of the answers. Okay, any questions? Okay, here, yeah.
Would you prefer us write at 2k pi or?
It doesn't matter. It's personal preference. I kind of like the k and with the 2, but it doesn't matter. Yeah.
That was gonna be my question.
Some people like the 2 and the pi together, and then you just multiply it by the number, and you see how how many circles you go around and stuff like that. Doesn't matter.
Sometimes 3 pi.
Sometimes you like what?
3 pi's.
Would 3 pi work on this?
No, it's like E3.
Oh, okay, I see. Little pun there. Okay. Grab your calculator, put it in radian mode, and let me show you a couple things about doing this on the calculator. Oops. So we're going to do x equals the cosine inverse of radical 3 over 2. So back to the calculator. Change the mode. Second quit. Cosine inverse radical 3 divided by 2. You said error?
Bob, you did it.
You might want to use a set of parentheses. You were probably trying to do the cosine inverse of radical 3 and then divide that by 2. It doesn't work that way. Okay, listen up. Why wouldn't cosine inverse of radical 3 work? It's over 1. Very good. It's not in the domain of cosine inverse. Remember, you need to plug in ratios that are between -1 and +1, including those. Okay, you can't plug in anything bigger. Okay, so that's probably why you got an error there. What's the issue with hitting enter on this? Do you recognize that?
Of course, it's 30.
You know, I haven't memorized my fractions of pi other than we did talk about 0. 3.14 would be pi. Pi halves is 1.57. 3 pi halves is 4.71. And we did talk about 45 degrees. 45 degrees is 0.785, I think, or something like that. Okay? But those are not things that we'd memorize. So if you're going to use your calculator to solve one of these, unless it's one of the really nice numbers like pi or 2 pi or something like that, which isn't going to happen very often, it's usually a good idea to have your calculator in degree mode so you can recognize the answer. And then if the instructions say write it in radian mode, you go ahead and make that change yourself. You with me? Okay, so I'm going to go back here and I'm going to change this to make it so we can recognize this a little easier. I'll recall that, although I could just hit enter. And notice that it says 30 degrees. Okay? Now, remember, when we were doing these, we drew pictures of the range of cosine inverse. What's the range for cosine inverse? Which quadrants? Okay, quadrants 1 and 2, 0 to 180, right? So your calculator is going to give you these answers up here. In fact, it does. It gives you this answer of 30 degrees, which we're going to translate into pi 6, right? Okay, if your calculator figures that stuff out, what's going to figure this stuff out? You're going to have to use your brain to figure this one out. Okay, now stop and think. It's as easy as thinking about, okay, I've got my reference angle. I just need to flop it into the right quadrant and have it measure the right thing. So I'm going to take this and flop it over here. How big is that reference triangle? 30 degrees. So this little angle right here is 30 degrees. And we make an adjustment on 360 degrees. We subtract a little bit from that, and there's our 330 degrees, or there's our, 11 pi 6, and here's our pi 6. Any questions? Okay, I'm not going to take the time to do this, but if we were to graph this, I'm not going to do it on the calculator, that's what it would look like. And we'd be looking for, where does this hit here? So there's our 30 degree answer, and there's our 330 degree answer. Or our pi 6 and our 11 pi 6, yeah.
So, is doing both the radians and degrees the answer you want, or are you just showing us how it is?
I'm just showing you how it is the same. Remember, there are 3 ways to solve this. You can solve it by thinking of the unit circle and triangles. You can solve it using your calculator, but again, your calculator's only going to give you one answer. Okay? You've got to think your way to all the other answers. Okay? And then you can use a graph to kind of confirm the answers. This is more just a point of interest. Okay? It's just kind of cool that it works out that way. And it's kind of cool that you can see, hey, you know what? How far is it from here to here? 2 pi. How far is it from here to here? 2 pi. You can see how often they repeat. Okay, any questions? Okay, because those are easy. It gets a little bit more difficult. Sure there are no questions? Okay. This one is not on your notes, but I want you to take a look at this. What if this original problem had been sine of x equals negative radical 3 over 2. Let's think about it. Y coordinate, right? Where would the y coordinate be? Negative radical 3 over 2? Down here and down here.
Yeah.
Okay. Then it is a 60-degree reference triangle, right? So this would be 240 degrees, and this would be 300 degrees. And then you'd add 2k pi or 360k is what you'd add on in degrees. Everybody good there?
Yeah.
So does everybody agree that these are kind of the two fundamental answers? These are the starting points, 240 and 360? Okay, grab your calculator, type this in. Sine inverse of negative radical 3 over 2. What does it give you? Gives you negative 60, doesn't it? It doesn't even give you, it doesn't give you either one of these, right? So what it gave you is one that's coterminal with this. So how do we make an adjustment to figure out the 300? 360, subtract the 60-degree answer, okay? Or add the negative 60 if you want to think of it that way. It's coterminal with this one right here. It gave you that answer right here. So your calculator gave you this answer right here. You're going to have to use your brain to figure this guy out over here. Any questions there? Okay, those are the basics. Let's solve some that are a little bit more interesting. All I want to do today is get through these next. I think we've got 4 problems to do. So let's take a look at this. What makes this one different than the previous 2 problems? There's a +1. It's okay. Look at the structure of these two. It was a trig function set equal to a ratio. Trig function set equal to a ratio. Is that a trig function set equal to a ratio? No. So we've got a little solving to do. What would we do first?
Add sign.
Okay, let me ask you this. It's always good to think in terms of, these are skills that you already had. If I had 2x plus 1 equals negative 3x, what would you do there? You'd add the 3x. You'd collect the variable term, right? You'd get the variable term on one side. So I'm going to add sine of x here, and I'm going to add sine of x here. That's going to give me 2 sine of x plus 1 equals 0. Next, subtract the 1. So this is going to be the sine of x equals negative 1, and then I get rid of the 2 by dividing by 2. Is everybody okay if I put those 2 steps together? Okay. Any questions? Now this is like the problem at the very beginning. This is like the first problem. Would you go ahead and solve this problem? And I'd like you to do this one in radians. Solve that one in radians, and we want all of the answers.
Sorry, did you say degrees or radians?
Radians.
Radians.
If you can do this one, you're probably in pretty good shape for the other problems. There are some tricky things about some of the ones coming up, but How we doing? Got it?
Good.
Okay. I like drawing the triangles the best. I use the calculator to confirm and do ones where it's not a common angle, but I like drawing pictures. So we want the sine or the y-coordinate to be -1/2. So I'd have one answer over here and one answer over here. So if this is -1/2, that would be the small angle on a 30, 60, 90. So our reference angle right here is 30 degrees. So what's the measure of that angle? 210. Okay, the angle from standard position would be 210. Okay, again, we're making an adjustment on 180. We're going to add 30 to 180. Okay, this one right here, we're going to make an adjustment on 360. So what's this angle right here? This is going to be 330 degrees. Okay, now, the answer is supposed to be in radians. So even if we think this, we've got to trade this and say, okay, I need to write this in radians. So this one is going to be 7 pi 6, right? And this one is going to be 11 pi 6. Okay. Did we do okay here? Yeah, we were okay. All right. So one answer set is going to be 7 pi 6 plus 2k pi. And then the other answer set is going to be 11 pi 6 plus 2k pi. Okay? And that would be all the answers. Yeah.
It doesn't matter.
Personal preference doesn't matter. Would this make you feel better? Okay. Lily feels better. Okay. I'm indifferent, so we're okay. Any questions there? Okay, if you tried this on your calculator is going to give you an answer in quadrant 1 or 4. What answer does it spit out? It says -30, which we translate into the coterminal one of 330 degrees or the 11 pi 6. Okay, and then we've got to use our brain to get over here, right? Okay, any questions? Okay, one adjustment on this. What if the instruction said this? Okay, answers between 0 and 2 pi. What if it only wanted answers that occurred between 0 and 2 pi? What would you say? Bob and Lily know the answer. Trevor? Anybody else? Several people. Peter, what would we say?
What would we say on that?
Yeah. So what if the instructions weren't find all of them, like write down the answer sets that produce all of them, because there's an infinite number of answers. What if it just said we only want the answers between 0 and 2 pi?
So we just write the first answer because we're adding 2 pi. We just answer it in terms of k equals 1.
Not even k equals 1, right? So, because if I did k equals 1, this would be 2 pi plus that. It would have to be k equals 0. So one of the answers is 7 pi 6, and the other answer is 11 pi 6.
We can't even add the 2 pi because of the instruction.
Yeah, because this is right here. That's between 0 and 2 pi. And if you add another 2 pi, that would be outside of 0 to 2 pi. Okay? Make sense? Okay, so again, make sure you pay attention to the instructions. Okay, let's take a look at this next one. Okay, this one is different. This one has a tangent. Please be careful with these. And again, you got to think your way through this. I think everybody here is capable of figuring out what the answer is, but we'll solve just like we did before. We're going to isolate the variable term, isolate the trig function. So I'm going to move a tangent from this side, right? So I'm going to have tangent of x is equal to -1, right? Okay, now, here's where it gets interesting. All the problems we've done so far, they were all sine and cosine ratios. They were x or y coordinates on the unit circle. Okay? And we could draw very familiar triangles for this. Okay, remember, this is an angle. What's this right here? It's a ratio. So let's make it a ratio. It's a ratio of what sides? Yes, it is a ratio. Yes, what sides? Okay, y over x, or we could say the opposite over the adjacent, right? So let's draw a picture of what this would look like. Okay, the opposite side needs to be -1, and the adjacent side needs to be +1. okay? Or the x is 1 and the y is negative 1. That puts me forward 1 and down 1, right? That puts me in quadrant 4. Does anything look familiar? Bob's hand is up as usual. Sometimes that means something, sometimes that doesn't. Okay? Bob?
It looks like a 45.
It is a 45, 45, 90, isn't it? Okay, we know what the reference angle is right here. Okay? Is 45 degrees the answer to the question? No, it's not. Okay? Because we would have to reference that from 360 degrees. This would be 315 degrees. We'll go ahead and answer this one in degrees. Okay? Everybody good there? Okay. Is there any place else? By the way, if you threw tangent inverse of -1 into your calculator, remember your calculator is going to give you this answer right here, but it's going to be -45, right?
Yep.
Okay. This is where your calculator gives you answers. What about the ones over here? We do have to think our way through it. So please don't say anything out loud. Look at that for just a second. I think everybody here can do this. Okay? This is not as easy, not as simple as just, oh, I just take this and I kind of flop it over the x-axis or flop it over the y-axis. It doesn't work that way. Okay? We can get our calculator to produce these answers, but we want to stop and think. I need the opposite over the adjacent to have a ratio of -1. There are 3 ways to write a negative fraction. You can write the negative on the top, which it is. You can write it out front, which probably wouldn't be a good idea here. Or where else could you write it? You could write it on the bottom. So let's say I take this, and I'll change colors so we can do this. Okay? Let's say I write it on the bottom. What's the x-coordinate now? What's the y-coordinate now? And where does that put us? That puts us back 1 and up 1. Still a 45-degree reference triangle, right? Okay. What would it measure from standard position?
90 plus 45.
Okay, or better to make an adjustment on 180. Reference angle is 45, so we're going to take 180, subtract 45, 135 degrees. So there's one answer, there's the other answer. Now, we have to say how often they repeat. So we could do this. Please don't write this down. Just watch. We could say, well, on the ones above, we just said, look, one of the answers is 135, and then we added 360K. And the other answer is 315, and we added 360K. Let's stop and think about that for just a second. Is that the best way to write these?
I don't know about this, but there's an easier way.
So here's an answer. How far is it? How many degrees between here and here? Isn't it 180 degrees? Aren't these exactly opposite from each other? Okay. And regardless of what the ratio is, even if it had been -1/2, all we're going to do is we're going to switch the sign, so it's going to look the same. It's just going to be in the opposite quadrant. It's going to be 180 degrees off. So wouldn't this be a lot easier to write the answers like this? Let's just pick one. Now, which one should we pick?
135.
Probably ought to pick 135 and add 180K. Okay. That's probably the best way to write it. Now, if we wrote 315 plus 180K, would that be okay? What if we wrote -45 plus 180K? Neither one of those would be as good as this. Usually we start with the smallest positive angle we can. Okay? So we wouldn't use 315 because 135 is smaller, and we wouldn't use -45 because it's negative. Okay? Not a huge deal, but this is just a little more standard way to write that. Okay, any questions? Does everybody see why these are 180 degrees off? Can somebody give me another reason why this ought to be 180K on tangent instead of 360K like it was on sine and cosine? Don't say anything out loud. Think for just a second. Think about all the stuff we've studied about trigonometry. Why would tangent have 180K on it while sine and cosine have 360K on it? Josh?
Well, I got 2 things. One of them is when you graph it, its period is pi.
Yep. That's exactly what it has to do with. So if I were to graph one period of tangent, it looks like this, right? And it's going to run into -1 right here. But if I graph another one over here or over here, how far is it from here to here? It's pi. It's 180 degrees. Because the period on tangent is pi, that's how often these answers are going to repeat. Okay? And the nice thing about this is, in one period of pi, you're only going to hit that ratio just once. Unlike up above here, where we hit it twice in one period, that's why there were two answer sets. Okay? Now, there is an exception to that. You're not always going to get two answers when you have sine and cosine. Like here we had pi 6 and 11 pi 6. Those are both starting points for answer sets. Can anybody think of where I could put this line so that it doesn't intersect it in one period more than once? Bob's hand is up again. Anybody else? Where could I put a line so it doesn't intersect twice between 0 and 360, between 0 and 2 pi? Autumn Rose? The vertex, the very top, right? So if this were cosine of x is equal to, what's the very top of the curve? 1. Or what's another place I could put it?
The bottom.
At the very bottom, okay? Those will only intersect it in one place, so they'll only have one answer set, okay? So we'd say the answer is 0 plus 2k pi or 360k. All right, any questions? Okay, let's take a look at these last two. We just need to do some algebra here. Let's take a look at this one. Anybody have any ideas on this? Yeah.
We can multiply both sides by cosine or sine or sine.
Okay, so multiply both sides by sine. Okay. Yeah. You'd want to be a little careful because if I divide by cosecant, it takes that trig function and all the answers that would go with it. Okay, so you want to be very careful about dividing and having something disappear. Yeah.
Would you subtract cosecant from the right, bring it on the left, and then take it out?
Sure, let's do that. Okay, so this is going to be secant x, cosecant x minus cosecant x equals 0. Okay, we definitely want it to be equal to a number over there. Are secant and cosecant your favorites?
Oh, absolutely.
Yes.
I would really prefer not. Okay, so let's think of this in terms of 1 over cosine of x. What's this?
1 over sine.
1 over sine of x minus 1 over, oops, not parentheses, sine of x. Any ideas? Okay, I want one single trig function over here. Okay, there are several different ways to solve this. But I want one single trig function over here set equal to a number if I can. Ideas? Yeah.
Did you factor out a cosecant?
Okay, you could factor out a cosecant or factor out the 1 over sine. And then I'm left with 1 over cosine minus 1. Right?
Mm-hmm.
Other ideas? You could have one of these on your assignment. What would you do? So a general rule would be, we like working with sines and cosines, but if you do this, you can finish solving it this way, but it tends to be a little more difficult. If we factor this out, Is there any problem with thinking about this in terms of, okay, could I think about these in terms of their graphs? And what I'd be solving for is, when does the cosecant of x equal 0? And this one would be, when does the secant of x equal positive 1, right? Okay, so think about the cosecant graph. Cosecant was reciprocal of sine, right?
Yep.
So that looked like this, and like this, and like this. Had those asymptotes and all that sort of stuff. Whoops. Okay, where is 0 on here? Right there. Does this graph ever hit 0?
Nope.
Okay, so no solutions from that one. Okay, let's think about this, the secant graph. Okay, and this is it's always good to have those. I mean, somewhere in the back of your mind so you can remember them. If this is 1 over sine, remember it looks a lot like secant. It's just been moved back. So this one has vertical asymptotes here and here. Has a piece here. Has a piece here. Has a piece here. Piece here. And we want to know where this graph equals what? Equals 1. Where would that happen?
There.
Right there
Right.
and right there. How far is it from here to here?
2 pi.
2 pi. So an answer that we get from this one is 0 plus 2k pi, or 2 pi k if you want to write it like that. Okay, everybody good? Okay, so even if you get something funky like that, so we kind of went down the wrong way for a second. You can finish it this way, and if you want to, be my guest. You'll get exactly the same answers. You'll get one factor that doesn't have any solutions, and you'll get another one that has 2. Okay, let's take a look at example 3, and then we'll finish up. Okay. It says it's usually easier to solve a trig function if the terms are written using the same trig function and the same angle. Same trig function, and notice that the angle here is x on both of these. Okay. This looks like a mess, though. Any ideas based on some of the stuff that we did up here? Lily? Okay, we could factor a cosine out of the 2 of these, but not out of this one. But you're on the right track.
We would add 1.
Bob?
Add 1 and then factor the cosine?
No.
Just add 1. and then
No. What's the math F word again?
factor.
Doesn't this look like a trinomial?
Yeah.
Squared term here, linear term here. So what we're looking for is 2 cosine of x. Cosine of x. We're looking for 2 things that multiply to be 2 cosine squared, and then 2 numbers that multiply to be -1 and somehow combine to be that middle term to be positive. So I'm going to have a 1 or a -1 here or here. The question is, which one's positive, which one's negative? So my question is, let's do the positive one. Where does the positive go? Does it go on this one, first one, or the second one? It goes on the second one. This is a plus, and that's a minus. Because if you multiply these together, you're going to end up with positive 2x, or sorry, positive 2 cosine x, and this is going to be minus cosine x. So does everybody agree this is the correct factoring? Okay. So on this one, we're looking for where cosine of x is equal to 1/2. And on this one, we're looking for where cosine of x is equal to -1. Okay? Now, if you want to draw pictures, if you want to use your calculator, if you want to think of the graphs, totally fine. Okay, I'm going to solve this one thinking of the unit circle, thinking of the triangles and so forth. Cosine of 1/2. X coordinate of 1/2. That happens here at 60 degrees, or they said radians, so this is going to be pi thirds. Where else does it happen? Calculator will give you these answers up here. We want the x coordinate to be positive still. We don't care about the y coordinate. It can be positive or negative. So this is going to be a reference angle of pi thirds, or what is this angle? 5 pi thirds. Okay. Now, do I need to write answer sets? Do I need to write pi thirds plus 2k pi? No, because it wants those answers right there. So there are two of them. And then let's do this other part. Cosine needs to be equal to -1. So where, as I go around the circle, does the cosine equal -1? Right over here, which is what angle?
180.
180 degrees or pi. So the answers are pi thirds, pi, and 5 pi thirds. Now, that's because, and I just want you to make note of this, that's because it said only answer between 0 and 2 pi. We get those three answers. What if it said all solutions? What would we do with every one of these? Add the 2k pi. Okay? All right. So that takes care of the first part of 5.3.